Yeah, what's up?
You want to learn some math?
Okay.
Yeah.
So, when are you gonna give me the math that you promised me?
Hey, you're gonna get your math when it's good and ready, but first I need to know, since math is such a broad subject, I need to know, what kind of math are you looking for?
My teacher's gonna do a test on logarithms, so I need to learn more about logarithms.
Alright, I can teach you about logarithms. Logarithms. So, logarithms are pretty much just the inverse of exponential formulas, alright? Developed in the 17th century. You know that, because that's where they started. Alright, so as you can see, this isn't a logarithm, this is a cubic, and it's very different from the logarithmic formula because they have different bases, alright? And so this one you would solve by using logarithms, and this one you would solve by taking the cube root of both sides. You see the difference?
Maybe?
Alright, I gotta call my boss, and then we'll take you to phase 2. But we gotta go to a super secret secure location, so you gotta put this on.
Okay.
Hello, I'm Gertrude the math dude. I heard you want to learn about some logarithms, huh? Well, this burrito is a common staple of Mexican cuisine, but as we can see, it is also the staple of logarithm formulas. This is a soft taco. It has the same insides as a normal burrito, but it is changed ever so slightly. As we can see, it has the extra H, meaning it can move left and right on a graph. This is a crunchy taco. It's a taco, but crunchy. The difference between the soft one and the crunchy one is the soft one moves left to right, while the crunchy moves up and down on a graph. This here is a quesadilla. It may not look like the other contents on this tray, but if you look closely, it's just like all the others.
Wow.
Take everything you just saw here for the final piece of resistance, the quesarito. It's got everything it has to offer from all these things. Look at this thing in all of its glory. It's beautiful. I can't imagine anything better than this. Here, I want you to take a bite of the quesarito of knowledge. What do you think you're doing?
What?
I don't know how to get through to this guy. We gotta take him to phase 3.
You sure?
Yes.
Good dinner.
Go.
Thanks for dinner, dude.
Oh,
That really
yeah.
filled me up.
No problem. Wait, don't change the subject on me. This is stage 3. If you don't pass this one, I'm just gonna have to kill you.
What? No, don't do that, dude.
Well, if you don't want to die, just learn. Don't resist.
What?
Don't
What do you mean?
resist.
Stop.
Don't resist.
This earthquake's off the charts. Look at it go, oh my gosh.
So now we need to figure out the Richter scale of the earthquake, where A is the measure of the earthquake wave's amplitude, A sub 0 is the amplitude of the smallest detectable wave of the earthquake, and R is the Richter scale, and the earthquake is measured with a wave amplitude of 584 times as great as A sub 0. So if we write out our equation, we have R equals log A over A sub 0, and A equals 584 times A sub 0. And so if we just plug A into our equation up here, we get log, R equals log 584 times A sub 0 over A sub 0. And those cancel out, and so we just get R equals log of 584, which is equal to 2.766.
see the potentials you have to learn?
Yes. And I want more.
Wait, what? No, that's all.
More!
Alright, so logarithms can also be used in chemistry to figure out the pH balance of a substance. So say that you have 0.01 moles of something and you add that to water, you would just plug that into this basic equation and you would get negative 2, which just equals 2, so your pH would simply be 2.
Now, go spread the word. He's gonna do well.
Want to learn some math?
Just what the heck?
Teach me how to do logarithms.
Oh, I can't hear you. You need to come over. What? Oh.
Teach me how to do logarithms. Stop, dude. No.